As we continue our counting principles, we leave permutations and come to what we call combinations. Now, combinations and permutations are pretty much the same coin, just a different side of the coin. So a combination, order doesn't matter. But with a permutation, order did matter. So in other words, if it matters how a race is finished, or in what order books are on the shelf in the library, or the firing sequence of cylinders in an engine, if the order in which things are counted matters, that's a permutation. We're suggesting that a combination is when the order doesn't matter. So if you go to a restaurant or a buffet, it doesn't matter what order you dish the food as long as you get the food. So it doesn't matter if mashed potatoes comes first and then carrots and then corn. As long as all three end up on the plate, it counts. So that would be a combination. A combination is where it doesn't matter what order things are in. It counts once. Here's a formula for combinations. Notice the difference here is that this is a formula for a permutation. This is a formula for a combination, so don't get them mixed up. So a lot of times we have to start the problem out by knowing what kind of problem are we dealing with. So let's not even do any math, let's just identify. If 5 runners are crossing the finish line, does it matter in which order they finish? If you said yes, it's a permutation. If you said no, it's a combination. So if it matters in how they finish the finish line because it's a race, how they cross the finish line, then this would be an example of a permutation. 12 books are arranged on the shelf. Arranged means order matters. That would be a permutation. If we are pulling at random, there's no particular order, it's just random, that would be a combination. And if we're selecting from a variety pack, well, the variety pack means that it's kind of random, that would also be a combination. So let's kind of revisit a couple of problems that we did a while back. Locker combinations. So recall that a locker combination has dials on it, numbers. Should it really be called a locker combination, knowing that we have the word combination in our vocabulary now? Well, a combination, the order of numbers doesn't matter. But the problem is that when you do a locker combination, we may know what the three numbers are, but we got to make sure we do them in the right order. Otherwise, the lock will not open. So because it matters what order these numbers are in, it really shouldn't be called a locker combination. It should be called a locker permutation. Now let's contrast that to Panda Express when we talked about the two entree combination plates. They actually call it a combination plate. Is it really a combination? Well, does it matter what order we get orange chicken or anything else? As long as it ends up on the plate, it doesn't matter what order it came in. So in that regard, a two entree combination really is a combination. So this one checks out. But the locker combination should technically be called a locker permutation because the order or the sequence of the numbers actually has significance. Problem 3. So let's look at the word solve. So let's look at the letters in the word solve. There are 5 letters. And the number of combinations of the letters, taking them 5 at a time and 2 at a time. So let's start with A, 5 at a time. So that looks like, and a quick side note here, remember this is the formula we're using. N must be bigger than R. It can be equal to, but it can be less than. Okay, so we're looking at 5C5. And what does that look like? Well, here's what that looks like. And if we simplify, this is 5 factorial over 5 factorial times 0 factorial. That's 5 factorial over 5 factorial times 1, sorry. Well, that's like 5, 4, 3, 2, 1 divided by 5, 4, 3, 2, 1 times 1, which is 1 anyway. And they all cancel out, right? So the answer is 0. No, the answer is not 0. What's 5 divided by 5? What's 4 divided by 4? What's 3 divided by 3? It's 1. So the answer is 1. So there's only one way to use the letter solve. Now you're thinking, Mr. What about SLOVE or SELOV? Oh, those are permutations. So what we're saying is that as long as we use all 5 letters, it counts. So this would be technically a repeat, and this would be a repeat, and any other 5-letter permutation is a repeat of, and so we only counted this once. Okay, so repeats that have the letters in different orders, that doesn't count for a combination. It counts for a permutation, but not a combination. Essentially, what I'm saying is this. If you have a pepperoni sausage pizza, it's the same as a sausage pepperoni pizza. It's the same pizza, okay? A permutation would say no, that maybe the toppings came in a different order. Well, no. A combination says it doesn't matter. You don't know if you ordered a sausage pepperoni pizza or a pepperoni sausage pizza. They look identical. Part B, 5 at a time. So we set that up. And we simplify this as 5 factorial over 2 factorial, 3 factorial. 5 minus 2 is 3. That's 5, 4, 3, 2, 1. 2 times 1 times 3 times 2 times 1. Now, a lot of you are very, very comfortable with crossing these out. That's great. Now, we can do this 2 ways. You could do 5 times 4 is 20. And you could do 2 times 1 is 2. And divide those and you get 10. Or you could say, well, 2 times 1, that's 2. And I can take a 2 out of the 4. So it's really just 5 times 2, which is 10. So what are the 10? Well, we could do SO. We could do SL, SV, SE. We can move on to the O, so that's OL, OV, OE. Move on to the L, that's LV, LE. And then move on to the V, that's VE. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, how do I come up with those? Well, see, like, okay, so you know how I got these, right? SO, SL, SV, SE. But how come I didn't do OS? Because OS is the same as SO. We're doing combinations, not permutations. If this were a permutation, then OS would be different than SO. Okay, but we're doing a combination, which means that these are the same. So I didn't count SO. I went ahead and ignored that. So I figured, okay, I'll just go OL, OV, OE. And then once I go to the next one, LV, LE, and then just VE. Because if I would have done anything before that, for example, if I did SV, or VS, right? Well, that's the same as SV. So we don't want to count that one because we're doing combinations, not permutations. So we mathematically said there's 10, and we showed you what those 10 would look like, right? These are 10 combinations that are unique, where there's no repeating, and we don't have any double dipping on order because order doesn't matter here. For your summary, you're going to want to write down some words. What are some key differences between permutations and combinations?